FileMaker calculations can draw in data from a variety of sources. If your calculation expression includes a reference to a field in the current table, then at the point when the calculation is evaluated, FileMaker will refer to the instance of the field on the current record, retrieve whatever value it finds there, or no value if the field is empty, and use it in the calculation. Something similar is true if your calculation references a field in a related table. For example, a reference to the function field here. Except that the value or values used in that case to evaluate the calculation will be those on the record or records that are related to the current record at the point when the calculation result is computed. Similarly, FileMaker can draw in data from sources such as variables and its own internal functions. For example, the calc function getCurrentDate supplies a value derived from the system clock on the computer or device that FileMaker is running on. Whenever you create a calculation that includes a reference to a source of data, and especially if that source is part of the structure of your database, you can be said to have created a dependency. The place where this concept is most important is in the creation of calculation fields in schema, in the data tables of your solution, where the calculation formula includes references to other fields in the database. In this situation, there are some important things to understand about how and when the calculation expression is evaluated, and more particularly, what circumstances will cause the result it produces to be updated. Now, for demonstration purposes, in this copy of the work file, I've created a couple of text fields called datafield1 and datafield2, and a test calc field, with the formula left datafield1 6. The left function will remove some characters from the left of the entry in the field supplied as the first parameter for the function, and the number of characters it will return is determined by the value you provide as the second parameter. So returning to the database, here in a new layout called Calculation Demos, the fields in question are on the layout. And if I enter a value into the first field, let's say Dependencies, the test calc result returns the first 6 characters of the value that I entered into data field 1. If I now change the value in data field 1, for example, if I enter the word summary, immediately the test calc result updates automatically according to the new input value in the field that it references. Back in the Manage Database dialog, if I change the formula for C test calc, let's say to data field 1 and a literal space, and then data field 2. Now we have 2 dependencies. That is, test calc depends on both of the input fields, data field 1 and data field 2. So if I put the word report into data field 2, test calc is recalculated to combine together the values it finds in both the referenced fields. So for example, I could use a situation like this to create a full name field out of a first name and last name field, as you saw me do in an earlier lesson. So we have Jan Travers. And now any changes to either of the 2 input fields will cause re-evaluation of the test calc result. So there's a 2-way data dependency within this record. In fact, the simplest and perhaps most common scenario you'll encounter is a calculation field that references other fields in the same table, as in this example. By default, calculation fields are stored, which means that when the calculation result is determined, it's written into the record as part of the file. That's efficient because the computation only has to be performed once, and the result can then be viewed or accessed many times. Also, storing the calculation result allows it to be indexed, which will speed up finds if the users perform searches with criteria in the calculation field. And the ability for the field to be indexed also enables the calculation field to operate as a key field on the source or target side of a relationship. So in short, dependencies on fields within the current record are automatically tracked by FileMaker, and a calculation result is re-evaluated when any of the values it depends on changes. That gives you an environment where the data in multiple fields in the record can remain consistent and where changes are dynamically propagated throughout the record. In that sense, conventional calculation fields in FileMaker can operate seamlessly. You set them up and they work, automatically updating their results on a record-by-record basis as the data they depend on changes. While calculation fields are stored by default, it's also possible for a calculation field to be unstored. You can choose to make a calculation unstored by paying a visit to the Storage Options dialog that can be accessed by using the button at the lower right of the Specify Calculation dialog. In the indexing section of the Storage Options dialog, you'll see a checkbox labelled Do not store calculation results, recalculate when needed. In some situations, FileMaker will automatically make a calculation unstored, whether you like it or not. For example, if your calculation references one or more related fields or global fields, FileMaker will change it to an unstored calculation as soon as you exit the Specify Calculation dialog. For example, if I create a new calculation, I'll call it Count of Functions. I'll use the Count function, select the Functions List table occurrence, and choose the function field. As soon as I exit the Specify Calculation dialog, you can see that FileMaker has made the C Count of Functions calculation unstored, as shown here in the Comments column at the right of the Manage Database dialog. A calculation being unstored means that the calculation result will be determined again each time the field is displayed or referenced. It uses more of your computer's processing resources because it has to be evaluated more often, but it uses less storage space and may generate less network bandwidth if the file is hosted. Other than that, having a calculation field be unstored has both advantages and disadvantages, depending on how you want to use the field. If you are hoping the field would be indexed to speed up finds and support value lists, then you'll find that having the field be unstored is something of a limitation. But for many other purposes, unstored calculation fields may be ideal. For example, if you have a calculation field that references system data, such as the current system time, if the field is stored, then it will be static. I'll create a field to show you what I mean. I'll call it C current time. I'll choose the calculation result of time and enter the Get Current Time function. Now I'll click OK to exit the Specify Calculation dialog, and you can see that C Current Time is not shown as unstored, which means that it's by default going to be stored. Now when I exit Manage Database, go to Layout Mode and add the field to the layout, go back to Browse Mode, you can see that the current time right now on this computer is showing as 11 minutes and 29 seconds past 4. I can navigate to different records and back again, and the time doesn't change. I can click into the field and the time doesn't change. It's now a little after 12 minutes past 4, and yet the C current time field is still showing 4:11:29. If I want the value to update, I'd need to make the calculation an unstored calculation, like so. Now you can see the comment indicates that the C current time calculation is unstored. And now, every time I click into the field or refresh the window, the calculation is re-evaluated and the current time is retrieved again from the computer's system clock. So the concept of dependencies between calculations and the various sources of data they refer to is a useful one, and having a grasp of the basic rules FileMaker uses to determine when a calculation result will be updated will give you a clearer picture of what's going on in your solutions and how you can make best use of calculation fields to meet a variety of requirements.